Number 10. Amber pushes a 1.35 kilogram book across the desk, accelerating it at a constant rate. Coefficient of friction between the book and the desk is 0.088. She's applying a horizontal force of 6.4 newtons. Draw a free body diagram. Calculate the force of friction. Free body diagram is a good place to start. So here's the book. She's pushing it across the desk. It's accelerating at a constant rate. So because it's accelerating, you know the forces don't necessarily balance out. So the applied force is going to be bigger than the force of friction because it's going faster and faster and faster and faster.
Attention, Michelle Cho, please report to the main office. Michelle Cho, please report to the main office.
There you go. Better get to the main office. Coefficient of friction between the book and the desk, they give it to you. She applies a horizontal force of 6.4 newtons. Okay? And we know the mass of the book. So the force due to gravity is going to be the mass of the book, which is in kilograms, 1.35, times 9.8. Alright, F equals ma, 1.35 times 9.8, so that's 13.23 newtons. The normal force, which is holding the book up, has got to be 13.23 newtons. Okay, otherwise the book would be falling through the desk or coming up off the desk. And they don't mention that in the problem, so the normal force has to equal the force due to gravity. Force of friction we can calculate. It's mu times the normal force. So the force of friction is going to be, did they give you the coefficient of friction? 0.088. 0.088 times 13.23. 0.088. Force of friction is 1.16 newtons. Okay, it makes sense. I said this was going to end up being bigger than that, right? That's cool. Alright, so the question that they ask is, draw a free body diagram, calculate the force of friction. Done. 1.16. Calculate the horizontal net force. So it's a tug of war, right? 6.4 going this way, 1.16 going that way. Who wins? The 6.4. How much do they win by? Let's figure it out. 6.4 minus 1.16. 6.4 minus 1.16. 5.24 newtons. That's your net force. 5.24 newtons. Going to the right. Dun, dun, dun. They give you a hint for that? Shouldn't need a hint for that. C, calculate the horizontal acceleration of the book. F equals ma. The net force equals the mass, which we know, sorry. We know the mass of the book, it's 1.35, times the acceleration of everything. We're using the net force because we want the net acceleration. How much is everything going to move? 5.24 divided by 1.35. It's going to accelerate at 3.88 meters per second squared. And they say 3.9, which is the same number. All right, cool.